Hi, welcome back to another tutorial. Today we're going to talk about solving a linear system by elimination using addition. And this is part one of 3 parts actually. So we're going to start by using an example and learning through example again. So find the solution for the system negative 4x minus 2y equals negative 12 and 4x plus 8y equals negative 24. So as it's implied in the title, what we're going to do is we're going to set these two equations up like this, where we're adding the two equations to one another. Now, if you look, the way this is set up, our negative 4x and our positive 4x, if we add those two together, we know that's going to eliminate our x's. Okay, why? Because negative 4 plus 4 equals 0. So we have 0 x's. Negative 4x's plus positive 4x's gives us 0 x's. So we've eliminated our x's from the equations. Now all we have left is negative 2y plus 8y equals 6. 8 minus 2 is 6y. And on the other side, we're going to do the same thing. We're adding these two equations. So negative 12 plus negative 24 is negative 36. Now it's just a question of finishing up the equation. So since we have 6 y's and we want 1, we divide both sides by 6, and that's going to give us y equals negative 6. So we found our y. Now we have to find our x. So we can substitute into either one of the two equations. I chose the red one. You could choose the blue one. It doesn't really matter. And we know that our y is negative 6. So we're going to substitute in negative 6 for y and evaluate and solve. So 4x, negative 2 times negative 6 is a positive 12. And that equals the negative 12 from the original equation. Now all we got to do is combine like terms and finish solving. So 12 minus 12 gives us negative 4x. We got rid of our constants. We got them all together on the opposite side by taking away that negative 12. And that gives us negative 12 minus 12 is negative 24. We don't want negative 4x's. We want 1x. So we divide both sides by negative 4. And that gives us x equals 6. So we have our solution to the system. X is 6. Y is negative 6. Now all we got to do is check. Since we used the red equation to solve, let's use the blue equation to check. So 4x plus 8y equals 24, and we know our x is 6, our y is negative 6, so let's substitute in, evaluate, and see what happens. 4 times 6 is 24, plus 8 times negative 6 is minus 48. Okay, and that's supposed to equal negative 24. 24 minus 48 does equal negative 24. 24 equals 24, so we checked. Negative 24 equals negative 24. The problem's done. Okay, let's look at another example. Now notice in this case, guys, once again, we have, they're not actually in standard form, but they're pretty close, because in standard form we know that the leading coefficient can't be negative, but we do have both variables on the same side of the equation. So they're kind of similar. The idea is, if you look back at the other one too, in both equations, both variables were on the same side and the constant is by itself. So that's the key to using elimination using addition, is most of the time you want to do it when you have both the variables on one side and a constant by itself on the other side. So it looks similar, if not exactly, standard form. Okay, so let's give it a try. We're going to add the two, the red and the blue equation together. And this time, you notice it's different. This time, the y is eliminated. Why? Because negative y plus positive y gives us no y's. So let's add the rest. Take away x, take away 5x. We took away 6x. We add on the other side, negative 1 plus 13 is 12. And now we just got to finish the problem. We don't want negative 6x. We want 1x. So we divide both sides by negative 6, and x equals negative 2. Now that we got x, let's find y. So I'm going to pick the red equation. You could pick the blue if you want, whichever equation you pick. All you got to do is substitute in your x and solve for y. So we've got a negative 2, because x is negative 2 from down here, and the negative was there from the original equation, right? So we're substituting in, and now we're going to solve. Negative times a negative is a positive 2, minus y equals negative 1. We want to get the constants together, so since we have a positive 2, we want to take away 2 from both sides. And that gives us negative y equals negative 3. How did we get negative 3? You take away 1, you take away 2, we've taken away 3. But we don't want a negative y, we want a positive y. So if we turn the negative into a positive, we've got to do the same thing on the opposite side. So since negative y becomes positive y, negative 3 becomes positive 3, and there's your answer. Let's check and see if we're right. So we're going to use the blue equation this time to check, and we know that our solution is at negative 2, positive 3. Let's see what happens when we put it in. Negative 5 times our x is negative 2, plus 3, which is our y, is supposed to equal 13. Negative 5 times negative 2 is a positive 10, plus 3 equals 13, and 10 and 3 does equal 13. So once again, we've checked our equation. Okay, now it's your turn. Here's 4 problems, and what you're going to do is find the solution to each linear system. You're going to show your work, and you're going to show your check. There are your problems. I would pause them, write them down on a piece of paper, and they're due next class, guys, so bring them with you. If you need more review, go back and check this video out, and also it might help to check out the other videos in the linear system packet. Okay, see you later.